What's up, guys? This is Teddy. Welcome to my YouTube channel. This video, we're going to be talking about the difference between the stack and the heap. And this is something that you will use on a daily basis as a programmer. Almost every single day, you will be maybe subconsciously thinking to yourself all the time, is this variable, is this going on the stack? Is this a reference type? Is this a value type? And it's really important to know the difference between these two because it will fundamentally shape how you view programming. So let's just start off from the beginning, the conception of when the stack and the heap actually occurs, or when this idea actually happens. So you will go into IntelliJ and you will press this cool little green button right here. Might press the bug button too, but what's going to happen is that literally Java is going to take all of your code that you have wrote and it's going to go through it and just line by line parse it. And parsing is just a simple word for it's just going to go line by line and research through all the code that you wrote, and it's going to determine all the variables, all the functions, where they go on the stack and the heap. It's almost like somebody just took a bag or whatever of just data types, dumped them on the desk, and it's almost like the compiler's job to just, pick each variable up one by one and just kind of determine, does this go on the stack? Does this go on the heap? And just for example's sake, we're going to play like we're the compiler and we're just going to do this mentally, manually, so that this can be solidified up here in your brain. So stack versus the heap. If you really just want the hack to know the difference between them, stack is for value types, aka dumb types, simple types, numbers, decimals, floats. These are all very simple data types that are stored on the stack. Also, functions are stored on the stack along with all of the values that are associated with everything that is in a function. A heap is for reference types. Reference types are objects. They are big. Whenever you think of reference, think big, complex. What would be another word for complex? Complicated. A lot of times, objects can be insanely complicated. That's like one of the. You can have objects inside of objects inside of objects, and if you try to store that on the stack, a stack is a relatively non-robust data structure. Sorry, stack. I didn't mean to insult you there, but it's for simple things. Heap, on the other hand, once you start getting into data structures and algorithms, you will begin to understand why stuff is stored on the heap. And the heap, just think big, complex. If you get confused about what a stack is, think dumb. But also, the stack plays another very important role. So we just clicked the green button on our Java program. What happens next? Hey, we just can't stop here. Well, first thing that's going to happen whenever you click that green button is your main function is going to be popped onto the stack. And the best way that I can describe a stack is literally like a stack of papers. I'm just going to try and make like a stack of stuff. And first thing we have here, let's just pretend the stack is empty. First, this goes on top of it. This goes on top of it. This goes on top of it. And with our stack, we can't just reach under here and just pull out things all willy-nilly. We have to take things off the stack in the order that we actually put them on. So if we're going to take stuff off the stack, we're going to do this. We're going to take them off one by one in the order that they were put on there, almost like a canister of tennis balls. A lot of people use the analogy of a canister of tennis balls. That's the very same analogy. You can't just reach in there magically and take out the bottom one. You have to take them out in the order that you put them in. So we've got our main. And let's just say we have another function within our main. So we're going to go back into, you don't need to type any of this out, but we've got our main. And then let's just say here we have another function, and we'll just call this one Pokemon Yell. Just a function we made up. It doesn't even exist, and that's why it's red. But let's just say we have another function. where is this going on the stack? It's going to go down here. So once again, Pokemon Yell is going to be stored down here, along with any other variables that were stored within the stack. So within our main, let's just say we had an int. So we have an int Pokemon number. We're just going to call it Pokemon number again. Don't know why. And this integer value is going to be stored along with the main inside of it. So just imagine that there's like a little separate box in here. And then within this, our integer number is going to be stored within our stack frame. And if we had a integer or we had a float or some kind of AKA stupid value, sorry stack, sorry primitive values, it would also go within the stack frame of the Pokemon. So this is where things start getting interesting. This is where things start getting confusing. What is the number one way that you can tell if something is stored on the heap? And this is kind of a trick question. Well, there's many different ways, but we've been talking about object references. We've been talking about objects. So if you were going to instantiate an object, we'll just give this this doesn't actually exist. What you would do is you would new it up. And this new keyword, and I briefly touched on this in one of my other videos in classes, this new keyword is what news up data on the heap because objects are complex. You will store a reference to the object on the stack. You see, the stack is there for value types, but a trick question is that even though it is a stack and it is a value type, the reference is going to be stored on the stack. And it's almost like you ordered such a big package to your front door that the delivery man said, Teddy, we can't have this on your front door because it's too fucking big. We have to store this at a warehouse and you get it whenever you want to because we're not going to drop this off on your doorstep because it's just too big. It'd be like if you ordered a car to your house or you ordered an airplane. They're not going to ship the airplane to your front door. They're going to say, hey, you need to go to the airport to get your airplane because we're not going to deliver an airplane to your front door because that's probably illegal. So if you had a stack and if your main function had, let's just see here, if your main function had, just for instance, this object type, whatever you want to call it, object is equal to object is equal to new, we're going to new up the object. What's going to happen is that this object is going to be stored within the main stack frame. But what's really going to happen is that even though you can access this variable within this stack frame right here, it's almost like the airplane analogy. It's going to say, hey, there's a variable in here, but we're not going to store this on the stack because it's way too big. We're going to store it on the heap so you can come get this later and we don't have to drop an airplane off on your front porch and get the police called on us. Another really important thing to understand is where can you visually see this stack and heap thing actually occurring? And one thing that not a lot of people teach is that you can actually see this occurring with your own eyes within the debugger. And I think that this is a really cool analogy. And I think that this is really important. So we're going to go here and let's just say we'll have int and let's just have two. We'll call this number 2 and we'll just put a 2 in here. And remember, these are value types. And now we're actually going to create our own object. So the way that we do that is we're going to go into new, we're going to create a Java class and we can call this animal, name it whatever you want to. It really doesn't matter. You could call it Pokemon, you could call it animal, you could call it dog. And then you go in here. And what we're going to do is we're going to go ahead and we're going to new up a variable and it's going to be a string. And we're going to give it name and then we're going to give it a name of turtle. I think this should work. Okay, yeah. So we've got that. Now let's go into here and let's just see how this thing actually works in action. And let's see what an actual object versus reference type looks in the debugger. So we're going to go animal. We'll call this a turtle, and then we'll go turtle animal. Go right here, and then we'll go animal. We're going to declare another animal, and this one will be a beaver, and we'll say new beaver, just like that. So let's go ahead and let's step in here, and this needs to be animal. And let's look at the difference between what a value type is and what a reference type is underneath the debugger microscope. So we're going to go in here, we're going to go ahead and run it. Remember, I pressed the bug button right here, and I set a red breakpoint just right here. Then I'm going to go down through here. Just use this button. We don't have any actual functions in here, so we don't have to worry about a step into. So we're going to go down. We're going to go down. We're going to go down. We're going to go one more, and then we're just going to take a look at the difference between a value type and a reference type. So if you look right here, notice the difference between these two objects. This one's got like this funky @ symbol, and this is the actual UPS man saying, hey, there's a airplane at the airport for you. This it's not here, it's not like actually in the stack, but it's where it's accessible if you need it. And this is what this animal @ 736, and what this @ is telling you is where it's located in memory. And why they include these, I honestly don't really know, because there's not really much you can do with them, but I guess it's fundamental to tell what the difference is between them. So I guess it's, it has that. But also you've got all these other variables, and all of these value types are being stored within this exact same object type. See, these are being stored on the heap. So here is where the value types are. These are just like themselves. They aren't changed in any way. They're not stored anywhere else. They are legitimately stored exactly on the stack. So as you can see, they are a lot simpler. But that's pretty much it. If you can learn that, that's 90% of object versus reference type. Pretty much all I know. And if that's good enough for me, it's probably good enough for anybody else. So if you like this video, make sure to hit that like button. Make sure to hit that subscribe button. And as always, thank you for watching.